Hello everybody, Zachary Fruling, aka Cozy Azeroth here. I'm going to do a little music type-in program. This is Pocket Canon. I presume it's Pachelbel's Canon in D. Yep, there we go. It says right here, Canon in D. Very, very short program, only a few lines. You can see the program description right here. I'm going to zoom in here in a minute. We're going to read this entire article and type it in. This program and this article are by S.T. Holl, and this is in Home Computer Magazine, Volume 4, Number 1. So without further ado, let's zoom in, and we're going to read this entire article first. And if you want to just skip ahead to the end and listen to the music and see how this short program produces some imitation of Pachelbel's Canon in D, by all means, go ahead. I'm going to read the entire article first, though, before we get to doing that. Okay, so here we go. Be seated at the keyboard, maestro, and play this little composition scored for the TI-99/4A computer. And we're going to look at the program in a minute here, but I'm going to keep it up on the screen for a second so you can at least get a look at it. Very short program, uses some data statements, complex formula here in the call sound statement, and so on and so forth. Pretty straightforward. If this doesn't work the first time you run it, and the error message is incorrect statement in 230, then check line 230 carefully. Did you notice that there are two closing parentheses at the end of the line? How about that single period, not comma, in 1.5? If the error message is data error in 210, be sure to check line 202. It contains 10 entries separated by commas. Because some of these entries are duplicates of others, it is not difficult to lose your place when typing them in. Now that you have the program running, let us discuss what it is you are hearing. A canon is a musical form in which the melody of the leading voice is imitated in some fashion by other voices or voices. The imitating voices can be at the same tempo and pitch as the leader, or they can vary either or both. When you started this program, you heard the theme alone played very slowly by the first voice. Then the second voice joined the first, playing the theme twice as fast and a perfect fifth higher. And finally, the third voice chimed in 4 times as fast and a full octave higher than the lead. A round, like Frere Jacques, or Row, Row, Row Your Boat, is a simple canon in which the imitating voices use the same tempo and pitch as the lead, but start at different times. Now, how did we pack all that into 8 program lines? The melody itself is stored in the 3rd through 10th entries in the data statement. You could substitute your own 8-note theme by replacing those numbers with new ones you have looked up in the musical frequencies table on page 37 of your user's reference guide. This particular theme comes from a celebrated canon of Johann Pachelbel. His harmonization is different, more complex, and much more beautiful from our childhood rounds. Pachelbel's Canon in D is the perfect accompaniment for golden sunrises, but well worth hearing any time. RCA Vector. Line 210 initiates 2 counters we'll need later, and then reads the frequencies of the notes into the vector F. You may think of a vector or array as a series of numbers all using the same name. To specify the first one, we use f of 0. The second one under the alias is f of 1, and so forth. Caution: when using vectors, always declare them first with a dim for dimension statement, which tells the machine things it needs to know to manage them properly. The advantage of using a vector to store our tune is that we can use an expression like n divided by 2 as the index to the vector, for example, f of n divided by 2. And then when the value of the expression changes, it refers to a different value of the sector f. Canons play themes over and over again, so we want to make an index for the f vector to go from 0 to 7 over and over again in a natural manner as our program executes. And we would like to be able to do this at varying speeds. The mechanisms which make this music box play Pachelbel's theme are compacted into 3 lines, numbers 220, 230, and 240. Line 220 is a define statement which establishes a base 8 modulo function for use within this program. We all routinely use base 12 and base 60 modulo arithmetic when we do problems involving time. For example, to find out what time it will be 19 hours from now, we add 19 to the present time and then subtract 12 until the hour is 12 or under. Since there are 8 notes indexed 0 through 7 in this theme, we need a transformation which will turn any number into its modulo 8 equivalent, then round that down to an integer. Line 220 defines such a function m. Try a few different values of x. You will see that this is true. Incidentally, this definition of m works for negative numbers as well as positive ones. We will not make use of that generality here, but it comes free, and if you pursue programming, you're certain to need it again somewhere else. So jot down the function, or maybe this magazine issue and page, on a 3x5 card and file it under modulo arithmetic. The purpose of line 240 is to increment by 1 the counter n each time it is executed until you reach 32. At this point, n is reset to 0 and the incrementing continues. The expression in parentheses is relational. During execution, that expression is replaced with 0 when it is false, with -1 when it is true. Line 230 is the one actually making the tones. The first of its 7 arguments is the duration of the sound. 500 milliseconds is about as short as the notes can be without producing gaps between them while the computer finishes the other things it needs to do in each iteration of the program. The remaining 6 arguments, separated by commas, are the frequencies and volumes of the 3 voices in pairs. Volume can range from loud, or 0, down to inaudible, 30. The volume for the first voice, which is the one playing the slowest tune, is set at 3. The volumes for voices 2 and 3 start at 30, but contain relational expressions which turn up the volume when the counter V, initially 0 and incremented by 1 every iteration, reaches 32 and 64 respectively. This corresponds to 1 and 2 complete playings of the theme by the first voice. Perfecting the pitch. Now let us look at how the 3 frequency entries work. In line 230 they are: first voice, f of m of n divided by 4, second voice, 1.5 times f of m of n divided by 2, third voice, 2 times f of m of n. The array is loaded in line 210 with the frequencies of the notes of the theme in the data statement in line 200. Voice 1 uses those values of f directly. Voice 2 uses the same frequencies increased by 50%. If you try this for several of the frequencies listed on page 37 of your manual, you will see that adding half again to the frequency will make it 5 whole notes higher. There will perhaps be a difference of 1 in the last place due to round off in the table. Voice 3 uses twice the frequencies in F. Can you tell from page 37 what the effect of this is? And we have this insert here. Pachelbel's Canon in D is the perfect accompaniment for golden sunrises, but well worth hearing any time. The expressions m of n divided by 4, m of n divided by 2, and m of n determine which note from the vector f is to be played during a given invocation of call sound. We already know that n goes from 0 up to 31 in steps of 1 and then starts over. We also know that the function m returns the modulo 8 equivalent of its argument. In the case of the first voice, this means that as n goes from 0 to 31, the value n divided by 4 increases by quarters. 0, 1 quarter, 1 half, 3 quarters, 1, 1 and a quarter, 1 and a half, up to 7 and 3 quarters, and m of n divided by 4 takes the values 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, etc. Since m rounds down to whole numbers modulo 8. In the case of the second voice, we have m of n divided by 2 running 0, 0, 1, 1, up to 7, 7, then starting over at 0 again as n passes its halfway point. The third voice goes 0, 1, 2, up to 7 4 times as n goes from 0 to 31. Now that you know where the theme is hidden, how the relative pitches of the 3 voices are set, and how the relative speeds of the 3 voices are determined, you should be able to write 8-note canons of your own. Themes of different length will require a bit more modification, to the modulo function for example, but not much more. Now go ahead and blast your canon. Editor's note, send in your best canons and fugues and we will publish as many as space in our letters column permits. Would anyone like to write an article and program to play ragtime? Okay, well let's get typing. Let's zoom in here, make this program as large as we can make it. Let's see if we can fit it all on one screen here. Alright, that looks pretty good I think. Yeah, there we go. That's the whole program, yeah. Let's get into TI Basic, and this is just regular TI Basic, right? Yeah, regular TI Basic. We don't need extended basic. So press 1 for TI Basic. I'm using the Classic 99 emulator, which emulates a TI 99 4A in a modern PC. And let's get typing. 100, remark, and we have 2 spaces, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 asterisks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 110, remark. Okay, we've got asterisk, space, pocket cannon, space, asterisk, 120, remark, 2 spaces, by Pachelbel, $130, remark. I think we're just closing up the box here. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 140, remark, by Holl. Holl. Hello, Holl. Hope you are still with us on this planet and maybe even stumble on this video I'm making of your old program. 150, remark, Home Computer Magazine. Oops, typo, Home Computer Magazine. There we go. 160. Mark version 4.1.1. Let's see, it was, sorry, 4.1.1. 170. I think we saw another remark statement there. Yep, TI Basic. We have a blank remark line on line 180. I don't know why we need to include a blank line there, just for readability, I guess. Okay, 190, here's our dim statement. Dim. Yeah, I see what I did there. Dim F of 7. There we go. 200. Data. Okay. So let's check our warning here. Check line 230. Okay, yeah, we're not going to worry about that yet. So it's like 0, 0, 0, 0, 262, 196, 220 and 165, 175, 131, 175 and 196. 175, 196. Let's double check that. 75, 196. Looks good. 210. Read. Okay, this is going to be a complicated statement here. It's like n comma v, comma, f of 0, comma, oops, f of 1 I believe I saw. Yep, f of 2, f of 3, all the way through f of 7. Okay, f of 2, comma, f of 3, comma, f of 4, comma, f of 5, comma, f of 6, comma, f of 7, comma. Okay. 220. Okay. Define m of x equals, that's where we have to be a little careful here, integer of x minus 8 times integer of x divided by 8. That looks pretty good. 230. Call sound. Okay, here's we got to be really careful here. 500, comma, f of m of n divided by 4. N divided by 4. In parens, comma. Yep, okay, here's our potential error of making a mistake here. Let's see, comma 3, comma, looks like 1.5 times f of m of n divided by 2, in parens, comma, 30 plus 29 times v is greater than 31. V is greater than 31. Comma. Two times f of m of n. F of m of n. Boom, boom. Okay, comma. 30 plus 30 times v is greater than 63. V is greater than 63, and I think we saw 2 n parens there. Yep. Boom, boom. Okay, that should be all of line 230. That's pretty good. I don't think we made any mistakes. If we get any errors, we'll fix it. Okay, 240. N equals n plus 1. N equals n plus 1 plus 32 times n is greater than 31. Okay, some Boolean variables there. Boolean values, I mean. I think that's all for line 240. Yep, almost done. 250. V equals v plus 1. And last line, 260. Go to 230. And we have a go to in 2 words. That's okay. Go to, I'll do it exactly as written here. Go to 230. Okay. Let's there we go. Take a screenshot of that. I'm just skimming it over really quickly before I run it. What I'm going to do, I don't see any typos or math errors. Doesn't mean there aren't any, but I'm going to go ahead and mute my microphone and let this program play. And if we did it correctly, we'll get some fugue-like version of Pachelbel's Canon in D. So I'm going to hit mute, type run, and let this program run, and I'll be back in just a minute. Hang tight. All right, well there you have it. That's some version of Pachelbel's Canon in D with a very, very clever program. I mean, it's pretty complicated for not too many lines. I mean, line 230 is doing a lot of the work there, and wow, that's pretty impressive for only how many lines? The program really starts at line 190, so not even 10 lines. Really, really good job on that. Let's list out the program one more time here. I want to get a screenshot of the whole program while I'm at it. And before I forget, I want to save this. There we go. Let's save this to DSK2, and we'll call this Pocket Canon. That way I can, make it easy for people to enjoy this program sometime after the fact. Let's make sure it's saved. And what I'm going to do, I'm going to run it one more time just to let everyone enjoy it for another minute or two. So I'm going to mute myself again and run the program again.